Hi there, how are you doing today? Namaste, good morning, afternoon, wherever you are. My name is Vishnu Dutt and I work as a network architect in Cisco. Today's hands-on lesson, we are going to learn about SD-WAN policies. But wait a minute, you must be thinking why we are on a blackboard if we want to understand hands-on or if we are having a hands-on session, right? So here is the thing. We are learning SD-WAN policies, and believe me, guys, there are many people who find it difficult, right? So, what I was thinking is, let's figure out a way so that we can understand SD-WAN policies uh, by comparing them with something which we already know, right? So we already know that how to create routing policies in our legacy networks, right? You all must be aware of access lists, right? You must be aware of route maps, policy maps, right? So what we are going to do is we are going to compare that whether SD-WAN is different than this, or if we know the concept of how we can create the legacy policies, can we utilize the same knowledge to create SD-WAN policies? And believe me, guys, SD-WAN policies are even simpler, right? So if you know legacy things, it is going to be good for you because SD-WAN policies are even simpler than the legacy one, right? So having said that, let's do a deep dive into our SD-WAN policies. And before going to our next board, right, what we are going to do is uh, I want to make sure that you understand this line. True knowledge seeks patience. And what is the meaning of that? The meaning is this video is going to be long, right? Uh, uh, I don't believe in creating videos for only 5 or 10 minutes to uh, just understand the overview. We want to go a little bit deeper into SD-WAN policies, right? So first, we will try to understand what exactly the SD-WAN policies are and how we can implement them. And believe me, if you are designing a network, right, SD-WAN policies understanding is a must there. Okay. So first we will understand SD-WAN policies and then we will configure them on a vManage on a particular network, right? So having said that, let's move to the board. So here is the board which I have created, and on the left hand side of the board, right here, you can see we are going to talk about the legacy policies, the things which you know, and we are going to take an example of Border Gateway Protocol, right, or the BGP. If you do not know BGP also, that is also perfectly fine. But believe me, it is going to be good. Means if you are a if you're a network engineer, you must have come across the BGP, right? But we are not going to talk about the nitty-gritties of BGP. We are just going to talk about how you are going to create some of the policies in BGP, right? And do not worry about this word policy, right? So when you create access list route map, there is some specific goals in your mind, right, which you want to achieve in terms of traffic pattern, and that is only your policies, right? We will be discussing that. On the right hand side, we are going to compare, right, what we have in SD-WAN as a policies, right? And believe me, if you can understand the left hand side of this picture, you are the right hand side is going to be pretty easy. So we are going to spend some good time here on the left hand side, right? So first thing first, let's try to understand what we are going to do here. We have three routers here, this R1, R2, and R3. These are connected over maybe some private network or a service provider, right? And the thing is that R2 can reach to R1, R1 can reach to R3, and R2 also can reach to R3, right? Very simple. Uh, Between R1 and R3, we are running eBGP. Okay. Between R1 and R2, we are running iBGP. And if if the AS number are same, then the protocol, the BGP protocol is going to be iBGP, right? If the AS numbers are different, then the BGP protocol is eBGP. Okay, but do not worry about that. Just try to understand that we are running BGP between R1, R2, and R3, right? And here's the thing: we have configured one loopback on every router, right? Here on the R1 we have 1.1.1.1. On R2 we have loopback 2.2.2.2, and on R3 we are having a loopback which is 3.3.3.3. Very simple. I think you understand this, right? Now, the company who is implementing this network, this complete network, wants to save some cost. So they go to their service provider, which has implemented this network here, right? And they say that I do not want the communication between R2 and R3. Would you what we can say? Would you cut some cost for me? And the service providers say yes, because now you are going to, because now R2 is able to talk to only R1 and R1 can talk to only R3. Then there is you can save cost, right? And it means that this company XYZ is moving towards hub and spoke network where R1 is going to be its hub site or maybe a data center, and R2 and R3 are going to be its branch side, right? But what is the issue here? We want to understand the issue. Now, there is a no connectivity between R2 and R3, right? First thing first. So BGP is running fine. And what we are doing is we are advertising all these loopback addresses, right? At R1, at R2, at R3 into BGP, right? So let's try to understand what is the routing table at R2, right? So at R2, we are going to see two BGP routes, right? Route number one, which says if you want to reach out to 1.1.1.1 right here, which is configured at this router, which is your R1, right? You need to go via x.x.x.x, which is the next hop, right? This one, this interface, pretty simple. Everybody knows that, right? If you consider the second route, it is going to say that if you want to reach 3.3.3.3, right, you need to reach it via z.z.z.z. And why it is the thing? Because R1 is advertising this route, but R2 is receiving this route via this interface right here. It's strange, right? It is not, guys. If you understand BGP, it is not going to be a problem. But if you do not, let's try to understand what I'm saying. In eBGP, when you advertise this route from R3 here to R1 here, right? It is going to be in R1 routing table, you will be seeing this route that 3.3.3.3 is learned via z.z.z.z here, right? And when this R1 advertise this route into IBGP, the eBGP route into IBGP, it does not change the next hop. There is a valid reason behind it, and if you want to understand that, you need to go to some of my videos which I have recorded on BGP, right? I will be providing you that if you need the access for that, right? But for now, R2 is going to receive this route via z.z.z.z. So there are ways you can change the next hop, and there are the provisions, and that is why you are creating the policies, right? But first thing, can you create this policy? Can you change the next hop, right? And if yes, how you are going to change the next hop? So there is a feature in the BGP. You can change the next hop, but we do not want to discuss that. What I want is, what I want is, I need to explain how you are going to change this next hop of this route uh, step by step. But wait a minute, why do you want to change the next hop? And the reason is now because the service provider is saying that R2 doesn't have reachability to R3. It means that R2 does not know how to reach Z dot Z dot Z dot Z. And if R2 does not know this, it means that basically this route is not going to be installed in the routing table of R2. And the reason is simple, because R2 can't reach the next hop, right? And this is the very first thing in route selection of BGP. If you cannot reach the next hop, then there is no point to install that route into the routing table, right? But yes, you can reach to x dot x dot x dot x. It means that if you can change this z dot z dot z dot z to x dot x dot x dot x, your problem is solved. And the company XYZ who was planning to implement a hub and spoke topology, you can make it by simply changing the next hop. Now consider how you are going to do this, right? So there are many tools available. As a first tool, I have already mentioned that in BGP, what you can do, you can change this next hop behavior, right? But we do not want to understand that. What I want to understand is how you can do this through some tools which are already available, right? So I believe you all know that you all know about access list, right? You know about route maps, right? Let's try to understand how we can use these two things to implement the same route policy. To change this network, R1, R2, R3 into a hub and spoke network where R1 is going to be your hub, right? R2 and R3 is going to be your spoke. So this is going to be maybe spoke 1. This is going to be spoke 2. Very simple, right? So first thing first, what you want to do here is you want to take this route in R1, right? In R1, you want to take this route 3.3.3.3, and when you advertise this route again into IBGP towards R2, you just want to change it next hop, and that is it, right? So let's identify this route, and to identify this route, we have several tools available, and the number one tool is maybe you can use access list or you can use the prefix list, right? These are the best tool in the legacy environment to identify the route, right? And suppose you create an access list, right? So what do you write? You write access list, maybe the number of this access list, and then you say permit. Permit what? You need to identify this route 3.3.3.3 slash 20 slash 32. Very simple. You have identified this route. But wait a minute. Does this access list has any meaning? If you just define it, no, it doesn't have any meaning at all, at all, unless you call this access list to somewhere, or you apply this access list to some interface or anywhere else, right? What I want to say is, if you define an access list, it doesn't have any impact on the router, right? So where are we doing all these activities? On R1, right? You have defined an access list, but it doesn't have any impact because you haven't applied it anywhere, right? Now, what I want to do is I want to change the next hop of this route to to x dot x dot x dot x from z dot z dot z dot z. So what I'm going to do is I am defining a route map. So route map is basically a simple logical statements, right? If and else statement where you can match and set some of the parameters. Okay, so what I'm going to do is I'm going to write route map, right? And route map, say I am going to write, say, route map ABC, and I'm saying permit 1. This is the first statement of the route map whose name is ABC, right? And now inside this route map, what I'm saying, match. Match what? Match ACL number 10. And if I'm saying match ACL number 10, what does it mean? It means that I am matching this route, correct? And now what I'm going to say, set next hop of this route to x dot x dot x dot x. Very simple. I have defined an access list till now. I have defined a route map till now. But do you think it is going to have any impact? Once again, no, because you have just defined them. You haven't called them anywhere or you haven't applied them anywhere, right? And believe me, guys, these are the concepts which we are going to use in SD-WAN also, right? SD-WAN also provide you several tools like access list, prefix list, but the names are changed because their impact is changed, right? But yes, we have the same things in SD-WAN also. If we define them there in UI and if we do not apply them, they don't have any meaning, right? So I'm emphasizing a lot that it doesn't mean that if you have defined an access list or route map, right, it is going to create any impact on this router R1, right? So how basically these two statements, the access list and the route maps, are going to create an impact. And by default, guys, everything is denied. So what I'm doing here is I am creating another route map statement, maybe the statement number 2, where I am saying this route map statement number 2 is permit everything, right? So for this route only, just change the next hop, right? And permit whatever the routes, whatever there are routes, right? And the whatever there are routes, just permit them, right? But if the route is 3.3.3.3, just change its next hop to x dot x dot x dot x. It is as simple as that. But now I need to apply this route map so that this route map has an impact. So I'm changing the pen so that you all can see. So where exactly I need to apply, right? I am right now at R1 here. When I am advertising route towards R2, it means that I have a BGP pair which is R2, right? So if I am advertising a BGP routes from R1 to R2, I need to apply this route map, right? So that whatever routes I am advertising, this route map will change the next hop of 3.3.3.3 to x dot x dot x, right? So what I'm going to write? I'm going to write in R1 that neighbor R2, right? Apply this route map, and the name of the route map is ABC, right? In outbound direction. Why outbound? Consider R1 as yourself, right? You are the R1, right? You have this route which is 3.3.3.3, which you have learned via R3, correct? And now you are going to advertise it towards R2. And if you are going to advertise it towards R2, it means that you are sending it in outbound direction, right? The route is going away from you, right? So what you are going to do, you are going to you are going to attach or apply the route map ABC in outbound direction. Now this route map is going to have impact on R1, right? Because what you are doing is whenever the route 3.3.3.3 is going out, right, it is going to change the next hop the route from z.z.z.z to x.x.x.x, right? Very simple. And now this access list is going to be it's going to have an impact. Why? Because you have applied this route map into the BGP neighborship, right? And this route map is calling ACL 10. right? And what there in ICL 10, 3.3.3.3. So now everything is making sense. First, you have identified the route, right? The second thing, you have uh, created your logic through route map. And the third thing, you have applied the route map into the correct direction or on the BGP neighborship, right? So guys, this is how you create policies in your normal network, in your legacy network, right? And believe me, if you give me another 20 to 30 minutes, right, the concept of SD-WAN policies will be, means it is going to be piece of cake for you, right? If you understand, if you already understand whatever I have covered in last 15-20 minutes, this is going to be good, right? No problems. But you if do not know that, then basically SD-WAN policies are going to be a little bit difficult for you. Okay. So having said that, let's move towards SD-WAN policies. So we are going towards right side of this diagram, right here. So consider this diagram here, and I'm again changing the pen to the orange one. Now, very important thing, and most of the things here, if you know SD-WAN control plane, data plane well, then are going to be pretty easy for you. But if you do not know, please do watch my fundamentals videos on SD-WAN, because policies is slightly advanced concept, right? If you do not know the fundamentals well, you are not going to understand policies. Believe me, guys, right? So here is the thing. We have replaced these R1, R2, R3 with H1, H2, and H3. Doesn't matter whether it's a VH or CH, no problems at all, right? These all these edges are connected to internet, and vSmart is also connected to internet, right? First thing first, what happens when all these edges comes up? They try to contact to vBond, right? And if they make a connection with vBond, vBond let them know where their company's vSmart is, right? Once they know where is the vSmart for their company, they are trying to make control connections, right? So E1 or the H1 is going to make a control connection with this vSmart. E2 is going to make a control connection with vSmart. And similarly, we have this thing here. Very simple, right? And these control connections are nothing but your DTLS and or TLS secure tunnels. Once again, do watch my videos on network security, right? To understand what DTLS and TLS is, and eventually why we are forming these control connections. But I want to make sure that you understand that first thing first which happens, these edges makes a control connection with vSmart, and over that control connection they run a routing protocol which is overlay management protocol, right? It is just like BGP here, right? You are running a routing protocol BGP here. Here you are running OMP. But the important point is E2 or H2 here does not have any peering or any neighborship with E1 or even E3, right? They only have peering with vSmart. And there is a proper reason for this. And that is where basically we are talking about software defined networking. We are just, what we are doing here is we are separating control plane with data plane. So right now, if you can see, all the edges are making OMP neighborship or the routing protocol neighborship with vSmart and not with each other, right? And once they make this OMP neighborship, and I am presuming that I am advertising all these loopbacks into OMP, right? Which is the default behavior also, that the connected routes should go into the BGP. So all the routes from the service side which are connected will be in the OMP, right? And now consider What vSmart is learning? vSmart is learning two things, right? So they differentiate the next hop as well as vRoutes. So if you can see here, we have vRoutes or the virtual routes. So whatever routes we are learning from the service side, those are virtual routes, okay? And we have TLOC also. TLOC is just nothing, guys, right? Whatever the IP address we have here, we are representing this IP address with three things, which is system IP, which is as good as the router ID, the color, right? And the encapsulation, because this IP address can be changed. So instead of identifying this interface with an IP address, they are trying to identify this thing with three different parameters, right? But eventually they are pointing towards this IP address, which is x dot x dot x, which should be somewhere here, right? Very simple. Do not confuse with it, right? So, but the important thing is how SD-WAN implemented all these things, that they have virtual routes and they have transport locations. Very simple. So vSmart will be learning all these route 1.1.1, which is at E1, 2.2.2.2, which is at E2 or Edge 2, and 3.3.3.3, which is at E3 over this OMP peering, because OMP is a routing protocol which is running between them, right? And believe me, you are not making this AMP neighborship and just like here, just like the BGP, because here you need to put the neighbor statement. But now SD-WAN is totally automated network, right? Whenever this control connections up with respect to vSmart, OMP is going to be coming up, right? Once OMP is there, you are going to learn all the routes, whatever you are advertising into the OMP, right? And vSmart, and that is why we call this is a smart device, and this is the brain, right? Because it knows all the routes, right? Previously, you have here, right here on the left hand side, you have chosen this place R1 to configure your policies. If I am saying policies, to configure your site, sorry, to configure your access list, to configure your route map, and then you eventually apply those on BGP neighborship right here, right? R1. But now we are talking about vSmart, which is the wholesale authority which is having all these routes. So whatever the routing policies we want to create, right? It is not going to work on E1 or E2 or E3. It is going to be it is going to work on vSmart. And the reason is because this is the guy who contains all the routes and all the TLOC information, right? So vSmart is going to have all the virtual routes. vSmart is going to get all the information about the TLOC, total TLOC, whatever TLOCs in your complete network, it is going to learn, right? Once this OMP neighborship is up. Believe me, these are important concepts. Now, once it learns all these things, it is going to advertise them back, right? It is going to advertise them back on the same peering. So if you consider the routing table of edge 2, which is here, right here, it is going to learn 1.1.1.1, which is the route present at E1 via x.x.x.x, right? This is the V route, and this basically this is going to be the TLOC. The TLOC, although I have represented with a single number x, but exactly what it contains. It contains, I am again repeating, system IP, it is color, and then cap. If you are not comfortable what I am saying, then please again watch my videos on the SD-WAN fundamentals. Okay. So it is going to have another route 3.3.3.3, right? Which it is which it is learned via z.z.z.z, which is the IP address somewhere here, and it is also going to learn the TLOC Z. And where exactly it is learning all this information? This is learning all this information from vSmart, right? And believe me, vSpot is not going to say that I am your next hop, because it is not, right? It is just, it is not in the data path. It is just saying I know all the routes, right? I know all the next hop. I am just forwarding all this information to you. It is as simple as that. Okay. Now, what is going to happen? Uh, Once this E2, E3, and E1 receives information about other transport location, the second thing they are going to do is they are going to build data tunnels, right? And what exactly that data tunnel is? Where you pass the data, right? And I'm going to showcase you that data tunnel with yellow color here, this one, because E2 now know X, right, which is the T-lock advertised by the vSmart. So it creates a tunnel between Y and X. Again, because I am not writing down all the tables of E1 and E3, E1 also receive information about Y and Z, which are the T-lock present at E2 and E3. And similarly, E3 is going to know about X and Y. So everybody knows what are the T-locks in my system, right? In my complete network. Once I know the information about all the T-locks, every edge is trying to create or will create a data tunnel if they have the reachability to it. So if Y has the reachability to X, it is going to create a tunnel, right? Similarly like this way and similarly like this way. So these are the yellow links where your actual data travel, right? Very simple. Now, again, because this company XYZ is now have been moved to SD-WAN, the company is going to be same. And now they are saying that, guys, what I want is I want E1 to be my hub site, right? And E2 and E3, this one and this one should be my spoke, maybe spoke 1 and spoke 2, right? It means that all the traffic from my spoke 1 to spoke 2 should not go directly, right? And if S1 wants to talk to S2, spoke 1 wants to talk to spoke 2, the traffic should go to hub first, and then it is going to be received at S2 or the spoke 2. Okay? I think you get it. It means actually this company XYZ does not want this data tunnel, right? This is as simple as that. And the problem is the same. And basically they want to implement a routing policy so that if E2 or spoke 1 wants to talk to E3 or spoke 2, the traffic should go from E2 to E1 and then from here to here and then from here to here. It is as simple as that. Correct? So now, previously we were able to do it pretty easily with the help of uh, with the help of with the help of access list, route maps, and then configuring those route maps over the eBGP peering. Sorry, over the eBGP peering. But now, what we need to do here? So to do that, let me clear this board first, right? Slightly, so that it becomes little bit less cluttered. Okay, let me clear this board. Okay, I am just removing everything from here. And now you try to understand that here, basically vSmart is going to learn all these routes and it is going to create tunnel like this, right? By default, it is going to create tunnel like this. And now the aim of this XYZ organization is that you should not have this tunnel at all. It means that they are converting your full mesh topology, or they want to convert this full mesh topology to hub and spoke one, right? Because company policies says that. And now it means you want to implement this routing policy. And if you want to implement this routing policy, you are going to use SD-WAN policies. It is as simple as that, right? So I have drawn this figure here, the left hand side one. Here the problem was simple. We were creating access list, then route maps. Now what we are doing here in SD-WAN, right? Because SD-WAN solution is the recent one. So they want to improve over existing one, right? But the concept or the fundamental are going to be same, right? So what they are doing is they are saying that to every site or every branch, whatever I have, suppose this is their data center or this is your branch or this is their campus, right? For every site, they are going to come up with a site ID or a number which totally identifies that site. Okay. For example, for E1, right, they come up with a number called 100, right? For E2, they come up with a number called, say, 1. And for E3, they come up with a number called 2. It's as simple as that, right? If I say site ID 1, right, vSmart is intelligent enough to know that if I am saying site ID 1, it means E2 or edge 2. If I say site ID 100, the vSmart is intelligent enough to understand that this is nothing but my edge 1, right? So it means that in OMP, when we are talking about OMP, we know we are sending information about this site ID also, right? And guys, believe me, this is one of the important thing. Just like we created access list in our legacy environment, we are going to create site list here. And what is access list? It is a way to identify, or it is a way to, yes, to identify a particular route or select a particular route. Here, site list is the way to identify a particular site. It is as simple as that, right? The aim is going to be same. Company policy says that you do not want this IPsec tunnel or this data tunnel. It means that it is going to create the hub and spoke topology. How you are going to create? So if I do that, then can I define a site list here? If you do not understand this word site list, that is perfectly fine. If you know access list, just try to understand from that, right? I am defining a site list number 1. Say the name of this site list is, say, my hub, right? And if I'm defining a hub, it means that it should contain a number of the site, right? And the number is 100. So if I have defined a site list hub, what exactly it is denoting? It is denoting my edge 1, right? Can I define another site list with the name of a spoke? Yes, of course I can, right? The second site list is spoke, and I have defined two numbers here, number 1 and number 2, right? It means that spoke represent two numbers, 1 and 2, which is eventually the site ID, which eventually E2 and E3, right? Very simple. But if I define this site list in the vManage or vSmart, is it going to have any impact? No, it is just like creating your access list. It is as simple as that. If you are not calling them somewhere, right, in some route map, then it is not going to have any impact, right? So believe me, guys, in SD-WAN, you are going to see so many things like this, right? For example, previously we have access list and then we came across the prefix list. And then there are so many tools like NBAR to identify the traffic, right? So there are so many tools which are there to ease our life, right? Because there are so many routing policies a customer can ask for, right? Or your boss on which or your boss of the company who want to implement some policies, right, can ask from you that I want this. So that is why there are a lot of tools in the legacy environment, and similarly we have a lot of tools in the SD-WAN environment. So when people just go into the UI of SD-WAN, they feel that there are so many things here and they get confused. Guys, believe me, right? These things, the things which are present on UI are your tools which you are going to use to create some policies, right? Which is asked by your customer or your boss, right? It is as simple as that. So do not worry about them. Just try to understand. I'm giving you a reference from your legacy environment. Site list is just nothing, but they are a way to identify uh, the branches, or they are the way to identify your edges into your complete SD-WAN network, right? When you create site list, it is not going to have any impact unless you call them, right? So the second thing, what you did there to implement this policy of removing this, the second thing is going to be the route map, right? And here there is nothing but the policy, right? But try to understand what you are going to do here. First, before discussing the policy here, the route map here, we are going to discuss how we are going to achieve this, right? So vSmart by default sends all the TLOC information. It sends all the TLOC information to all the edges, right? And if it sends all the TLOC information to all the edges, that is the reason why all edges created this data tunnel at the first place. So if by any means, if you can stop sending of this TLOC information, right, then they are not going to make this tunnel, right, the data tunnel. And right now, what do you want? You want that E2 should not receive this TLOC information of E3, and E3 should not receive TLOC information of E2. This is what you want. If they do not receive this information, this thing is not going to be there. But what exactly you want? That E2 and E3 should only receive TLOC information of E1, right? Nothing else, right? If you can do that, E2 is only going to have X or TLOC information of E1. E3 is only going to have TLOC information of E1, and that is it. They do not know each other, and if they do not know each other, there is not going to be any tunnel. This tunnel is not going to be there. And if there is no tunnel, if this Z is not reachable at all, it means that this route is not going to be reachable at all, right? And if you know that if your next hop is not reachable, it means that this route is not going to be installed in your routing table. And if this route is not going to be there in your routing table, then what exactly uh, then if you try to reach 3.3.3.3, it is not going to go from here to here anywhere, right? So what do you want to do? If I say Z is unreachable, right? But X is reachable. So is there any way, just like here, where I change the next hop, is there any way can I change the TLOC information from Z to X? That is what I want to do, right? If I change the TLOC information of this route from Z.Z.Z.Z to X.X.X.X, right? My problem is going to be solved. So I need to change at two places. One, I need to send only TLOC information of my hub side E1 to E2 and E3, right? Not the spoke information, not the TLOC of a spoke, right? The second thing, when I advertise this virtual route, which is 3.3.3.3, right, from vSmart, I'll make sure, right, that it is going to have the next hop of my hub site, which is X. It is as simple as that, right? So in policy, what I'm going to write, right? Permit only hub, sorry, just wait a minute. So what I'm going to write here is in policy, permit TLOC of hub only, right? And the second thing, what I'm going to write, permit all routes, right? Permit whatever the route means, there is no restriction. Permits all routes And if I say route, I am saying virtual routes. Permits all virtual routes, but make sure when you advertise them, you set the next hop, right? Or the T-lock to hub T-lock. Can you get these two information? Sorry, can you get these two lines? The lines are simple. First, I am saying permit T-lock of hub only, right? If this vSmart is advertising every routes towards E2 and E3, right? Now I am, and believe me, guys, I am going to create all these policies on vSmart, right? So if this vSmart, right, is advertising the routes or T-locks towards E2 and E3, I want to make sure that permit T-lock of only hub. That is it. So this is going to be my route map kind of a thing, right? Where I'm saying that when vSmart advertise route towards E2 and E3, okay, it should advertise only T-lock of my hub, which is only X, this one, right? First statement of this route map or the policy guarantees that I have only these two tunnels. That is it, right? And the second statement of this route map or the policy is responsible that whenever this vSmart send any virtual routes to E2 and E3, it is going to change the next hop to hub T-lock. And what is the hub T-lock? Hub T-lock is going to be this X1, right? So instead of 3.3.3 via z.z.z.z, you are going to receive it via x.x.x.x, and this is going to be changed at X. It is as simple as that. But wait again, but once again, this route map is not going to have any impact unless you apply this route map or policy, right? So who is the brain, right? Where exactly all the routes of your system are, of your SD-WAN fabric or SD-WAN network is? All the routes are on vSmart. And this is the place where you want to apply your policy. So now, just like R1, right? You are going to implement this policy on the vSmart. Presume yourself as a vSmart. Now you are vSmart, right? You are the most smart, you are the smartest people here because you know all the routes. And when you advertise all this route, you want to make sure that this policy hits, right? So what you're going to do is, whenever you advertise these routes to my spoke, right? And you have defined this spoke here as a site list. If I am saying spoke, it means 1 and 2. So you are saying you are the vSmart. If you're advertising anything, T-lock or virtual route to these spoke, just make sure that you apply this policy. And in which direction? This policy is going to be in outbound direction because you are advertising routes towards these edges over the green tunnel, right? Over the OMP tunnel, right? So when you apply this, just like you apply the route map on neighbor statement, what you are going to do is you are going to apply this policy in outbound direction, but to where? On the spoke. And what exactly the spoke is? Spoke is your site list where you have defined number 1 and number 2, which are your edges and nothing else, right? And if I am calling in this route map hub, what is the meaning of this hub? The meaning of hub is site 100. If I am saying permit T-lock of hub, I am saying permit T-lock of site 100. What is the T-lock of site 100? T-lock of site 100 is this X value, right? If I am saying permit all routes, and set the T-lock to hub T-lock, and T-lock of the hub is X, and that is why whatever the route I am advertising from this vSmart on edge 2 and edge 1, it is going to be having the next hop of X, and that is exactly what you guys are doing. So believe me, it was as simple as that. First, you are creating your site list, right? Second, what you're going to do, you are creating your policy. It is as good as your access list, right? Second thing, you are creating your policy, which I somewhat call the T-lock control policy or the route vRoute control policy, right? The policy, basically the centralized one can have two parts, T-lock or route, and this is as good as your route map, right? Third thing is you are going to apply this policy in outbound direction when you are advertising routes uh, towards your spokes, right? And here also, basically in your legacy environment also, you attach the policies. Means if you are creating the BGP policies, you are going to attach the BGP policy on the neighbor statement, right? Very simple. Now, if you do not get it, just watch this video as many as time. Just watch my previous video on SD-WAN fundamentals. If you understand all these things, then we can move towards hands-on. Okay, so we are going to see exactly this thing in our hands-on video, right? Which so let's move towards our hands-on video, or basically let's open our vManage uh, to create all these things whatever we have learned in this video. Okay, this is good. So here you go. So we have this topology, and if you are following my previous videos, right, you know that what we have done till now. Okay, so just for a recap, we will try to understand what we have built until now, right? So if you can see that we have this data center site here, right? Let me just give me some time. We have data center site here, we have branch 1 here, and we have branch 2 here. So what we have done till now is that my edges, the BR1 edge is up, BR2 edge is up, and this BR2 VH1 is also up, right? So branch 1 edge, branch 2 edge, and the data center edge is up and running. So I have created this network like this. This is my DC, this is my branch 1, this is my branch 2, and then basically uh, all these edges are up and running, and we are making the data tunnels like this, right? So right now, if you can see, we have a full mesh, and we, by the way, guys, we haven't introduced this MPLS till yet, right? So we have only internet transport, right? So we are building tunnels like this from DCH to branch 1, from DCH2 to branch 2, and from here to here, right? This is the full mesh tunnel which we have till now. And if you have seen in my previous video, I was successfully able to reach from branch 1 to branch 2 directly, right? And from branch 1 to DC1, and from DC server, and from DC server to here, right? So we have a full mesh connectivity. So, but what we want to do now, right? What we want to make sure that we create hub and spoke topology such that my data center edge is here and my branch is here, branch 1 and the branch 2. So I should have only data connectivity between data center to branch, data center to branch 2, and there should be no connectivity between them, right? So we just explained how exactly policies work. right? So what exactly happened? This DCH2, when it comes up, it was going to create a TTLS tunnel or the OMP pairing with vSmart, and it was sharing all the routes to this guy, right? And what we are going to do is we are going to do site list, create site list, which will be identifying my hub. So my hub is going to be this 100, right? My spokes are going to be uh, this one and this one. And the site ID for these two is 1 and 2, which you can see right here. Very simple, right? And then I will create a policy, a topology policy, where I will going to say that when vSmart is going to advertise these routes towards branch 1 and branch 2, right? It's going to change the next hop to the data center. And then I will say when you advertise the T-lock, you advertise only the T-lock of data center to branch 1 and branch 2. As simple as that. And then we are going to apply this policy to where? We are going to apply this policy to vSmart in outbound direction to receive this, right? To basically to have the desired topology. So we want to create a topology such that right now it is DC branch 1. I'm repeating this once again, branch 2. Right now the topology is like this, right? We have all the tunnels, we have all the routes everywhere. What we want is, we do not want this, and when BR2 advertise a route to BR1 via DC, right? It should be via DC and not directly to each other, because once this tunnel is going down, then there is no way this branch 1 can reach to branch 2. This is as simple as that, and we are going to do this. Okay, so having said that, let's bring our vManage into the picture. So right now, okay, there is some issue with the some issue with respect to desktop, remote desktop connectivity. So give me a minute time, guys, and I will be back. So I have resolved the remote desktop connectivity problem, right? So now I am here, and where exactly, if you can see my main dashboard, you can see everything is up and running here. No issues, no problem with respect to this, right? We have 3 WAN edges, 1 data center, 2 branches. We have 1 vBond. We have all the 3 control connections from these V edges toward the vSmart are up and running. No problems at all, right? What we need to do is we need to create the policy, right? So for that, we are going into the settings. We are going into policies. And here you go. We are right here. Okay. So now there are 2 ways. You can use the default flow, or we can use the way which we have learned, right? We will be defining the site list first, then we are going to define the topology or the route map, and then we are going to call this route site list and topology into the main policy, right? Where we are going to apply this. So let's choose this way. Just click on this right hand side part, right? Custom policy or the custom options, and just go to the lists here, right? And here you can see many options. So guys, do not fear with them, right? These are to ease your life. Right now we will be working on this site list, this one, but believe me, we have prefix, polisher, data prefix, color, right? Application to identify some of the traffic, then T-lock and the VPN also, right? Everything is there to make your life easy. Right now we are achieving, or we want to achieve, the hub and spoke topology. We are going to achieve it via site, but there may be many other ways to do that. Okay, it is as simple as that. So I'm just clearing this and just going into this site portion, and let's create two site. One is hub and the other one is a spoke. So guys, believe me, this picture is going to be very useful if you can just take a screenshot of it, and so that you can be aware the data center site is number 100, branch 1 is 1, and the branch 2 site number is site 2, right? If you are following all of my videos of hands-on videos, then you must be knowing these numberings, right? So if you go here, now let's create a new site list. So it is as good as the first step. We are defining access list, or we are defining here the site list, right? The name of the site list here is going to be hub. Okay, very simple. And which site is going to be part of this, right? Which site list? Only 100, because I have only one data center in my topology, right? Let's create this. So I have created this hub, very simple. Now what I'm going to do is I'm going to create another site list with the name of spokes, right? And spokes is basically you can see right here that you can separate them by a comma also. So the branch 1 is represented by 1 site ID, and the branch 2 is represented by 2 site ID. It is as simple as that. Let's create this at very simple. So we have two site lists, right? And as I mentioned, these site list is not going to have any impact unless you specify them, unless you what we call attach them, right? Somewhere. So the second thing, this is as good as defining the access list. Now we are defining our what we call a route map or the policy. So again, I'm going to the custom options here, right? I'm going to say I want to define the topology, right? So we are just doing a building blocks, guys. Okay. So I am into the topology part, and I want to add the topology. So it is going to say whether you want to choose hub and spoke, mesh, or custom control. Guys, I can simply choose hub and spoke, right? But the problem is you are not going to get the intent. You are not going to get the whatever we have discussed in those 55 minutes in the beginning of this video, right? We are not going to take the not going to take the already ready-made option here. Although you can just choose this, just define your hub and spoke site, and you are you are good to go. But believe me, you will learn more if we choose custom control. And right here, you can see that we have routes and TLOC. Routes mean virtual route. TLOC means TLOC, right? And we need to build everything on the basis of this route, right? Route and TLOC. First of all, what we are going to do, we are going to say that only advertise TLOC of hub to the spokes. And the second thing, when you advertise routes, just change the next hop to the TLOC value of hub. That is it. If you didn't get my last 2 or 3 statement, just see this video once again, because from the beginning we are trying to do this. Okay. So let's have this custom control. Here you are. First thing first, what we are going to do, we are going to specify a sequence type. Which sequence type? I want one route and one TLOC. So let's define first TLOC. Okay. So here you go. And I am going to add a sequence rule here. And now you are going to see this, right? What you want to do here is you want to say to my site list, okay, and site list, it is going to let you select, right? I'm going to say I'm defining a TLOC route, and in which I'm going to say just advertise only the hub TLOC and nothing else to these spokes, right? So I am selecting this hub, and I am saying just permit it. Okay. So basically, if I want to go to action, I want to say permit this, right? and instead of doing reject, I am saying permit. And by default, guys, there is a default deny. Default action is always going to be deny, right? So it is only going to permit only hub keylock and nothing else, right? So what I'm going to say, I'm going to say save, match, and action. Okay. So in the first thing, I am just going to say while you advertise this T-lock information to my spoke site, you just select only hub and nothing else. Now the second rule is going to be the uh, second rule. I do not want the T-lock rule. Okay, so just cancel it. Okay, just leave it. I think I made a mistake, guys. Here, let me first define the name, right? Sorry for that. Sorry for this. So I am going to say this is my uh, hub and spoke topology. Okay, and I'm going to add here sequence type, which is going to be T-lock. And here I am adding the sequence rule in which I'm going to the site, selecting my site as hub, and then changing the action to accept. And that is it. Save, match, and action. Now I'm going to specify another sequence type, which is going to be my route this time. I'm adding a sequence rule here. I'm saying match. I do not have any matching criteria because I want all the routes to be advertised to this. But in the action field, what I'm going to say is just accept the action, right? And change the T-lock. And what do you want to change the T-lock from? You can define the T-lock list also, or you can define the T-lock color, IP, and encapsulation. So believe me, guys, what we are going to do here is we are going to define the IP system IP of this guy, DCH2, and the system IP of this guy is 192.168.200.202, right? So we are going here, we are saying I have already defined somewhere. So 192.168.200.202 color is going to be biz internet because that is the only thing which I have as a color, and then the encapsulation is going to be IPsec. What I'm doing here, just try to understand, right? I am saying when I advertise my routes, all the routes from my vSmarts towards the edges, and which is spoke 1 and spoke 2. I will be specify these things in the next section, right? Where I am going to apply this. So wherever I am sending all the routes to spoke 1 and spoke 2, any route, it should be with the T-lock of my data center router. And what is my data center router T-lock? These are the three values which are specifying it. Okay, as simple as that. I am just removing this. I am doing the save and match action here, right? And then I am going to say this T-lock is good and this one is good. Let's see the T-lock accepting only the hub from here. That is perfect. And from here I am saying this thing. This is again perfect. And at the third step, the default action is reject. So I am going to change it to accept. Okay, so I do not care about the other routes also, right? So other routes will be accepted. So having said that, let's do a save control policy here. So we have the hub and spoke policy also. But now the question is, we have defined site list, and site list is just nothing, but it is as good as your access list. We have defined the topology policy, which is nothing but as good as your route map, right? The third thing, which is another important thing, now I need to apply this policy towards on the vSmart in outbound direction and exactly to my spokes. Okay, so to do that, what I'm going to do is I am going into my centralized policy, and now in this policy I am going to call whatever the component I have created, right? Add policy, I am going to say. I do not want to define anything here because I have already defined the site and everything, right? I am going to do just next here, right? And it is saying add topology. So here I can go and add import existing topology, and the existing topology is my this one which I have already defined, hub and spoke, right? Very simple. I am going to say import this, and now in the next step it is going to ask me whether you want to define some traffic rule like application aware routing traffic. I'm not I do not want to configure them now because I do not want to configure any app aware routing now, right? If you do not want to create anything with respect to this, you can just simply do a next here. Okay. When you do a next here, you will be on this page, and this is where exactly you are saying whatever you have defined, like your access list means site list or route map like topology information, you need to mention here where exactly you can define, you need to mention here where you want this policy to be implemented. And here, this is my full umbrella, you can say, and I am writing this as this was my intent, and this was my policy, right? You can say the, and by the way guys, you can have only one umbrella in which you can have multiple topology, multiple application aware routing policies, but you can have only one policy, right? The outbound umbrella. But yes, inside that you can have multiple policies. So intent, I'm giving it is just a name. And now where this is the hub and spoke, the custom control policy which you have, right? And now here you are saying which direction, inbound site list and outbound site list. So here I am selecting spokes because this direction is going to be when you are advertising this route towards the spokes, right? In outbound direction. That is why I have selected outbound site list, right? I'm just doing a save policy. Okay, so it is saying add VPN list or site list to component hub and spoke. Okay, just wait a minute. Just wait a minute, guys. I think I made a mistake. Just wait. So guys, the mistake which I had did was actually if you go in this topology, right? And if I do an edit here, so the default action was I accidentally or made it permit, right? But consider the fact here, we are just saying only the hub TLOC should be advertised. All the routes should be advertised, but with the next hop of uh, all the routes are going to be advertised, but with the next hop of the hub, right? And which we have specified right here, right? And then the default action, we are going to say that basically everything should, apart from whatever we have defined, we do not want anything to be go there except this, right? So save control policy, this is already there. And now I am going to centralize policy, and I'm saying now this is the umbrella as I mentioned. I'm saying next here because I have already defined the add topology. I'm going to say import existing topology. Here you go. Here the hub and spoke one, import, and then we are good with respect to this step. I do not want to configure any VPN membership and then application aware routing. I do not want to do that. I am here. This was my intent. So this is the final policy or the umbrella of all the policy. It is always one, and we can define many policies inside this single policy or the umbrella. Now, as you can see, this is my topology, hub and spoke, which I have already defined. And now here you can say, I am going to say that it should be go on the spoke, right? The mistake I was doing is I was not adding this button, right? And now this is good. Now it is time to see, because we can right now see what is the preview, right? What exactly it is going to look. So believe me, guys, it is always, if you want to read this policy, it is always good if you can read from bottom to top, right? It is slightly, I find this way of reading pretty intuitive, right? So where I am applying this policy, right? I am applying this policy to site list spoke. So I am drawing this, right? This was my hub, this was my spoke one, and this was my spoke two. Okay. And I am here, exactly here, V smart. Okay, let's make it consistent because I have always drawn V smart there. So let's have our V smart here, right? So the policy which I am going to create is in the outbound direction. So these are the two OMP tunnels. Although there is an OMP tunnel for a hub also, but what I'm doing here is whenever I advertise route to S1 or S2, and that is where my policy is. Policy is on spoke. And what is this spoke, right? You can see the spoke site list right here, which contains site ID 1 and site ID 2, right? So I am applying this policy on my spoke number 1 and spoke number 2, and where in the outbound direction, right? So that is why this number out. And of course, if you can go and check this this thing here now, if you go and check here, it is saying that sequence number 1 says for site list means match site list hub, right? This one here. Okay, let me just wait a minute. Yes, site list hub, and hub is what? Hub is site number, site ID 100. It is saying just accept this, right? You need to accept TLOC of only hub while advertising this. Although we are having TLOC of hub, TLOC of S2, TLOC of S1, which is my spoke 2 and spoke 1. But what I am going to advertise while advertising to S1 or S2, I am only going to advertise TLOC of hub. It means that S1 is going to see this TLOC value only, right? This one, suppose this is X, they are going to see only X, and S2 is also going to see only X. It means that they can create tunnel like this, and there won't be any tunnel like this, right? So the first statement is saying where you are going to make your data tunnel. Guys, it is very, very easy to understand, right? It is as good as your route maps, but just make a habit of reading from bottom to top. It is more intuitive that way, right? Now the sequence number 11 here. If you see match route, now we are talking about match, we are now talking about the matching route. So there basically I haven't defined anything. So it means that it is applicable for all the routes, right? All the routes means 0.0.0.0 slash 0 less than equal to 32, which is specified here. Although I haven't specified this while configuring my policies, right? But if I don't specify, it is means the V manage is smart enough to create this for me, right? Now I'm saying action is accept means you advertise all the routes from vSmart towards where? Toward the spoke, because this policy is for towards the spokes, right? But when you advertise it, just set the TLOC to data center or my hub TLOC, which is 192.168.200 or 200. Color is this one. Color is business internet, and encapsulation is IPsec. It is as simple as that, right? So this guy is going to receive the route of S2, but with the next hop of X. Now let's see everything in action, right? So if you don't understand this, just repeat this video. I am again repeating. It is going to be good when you start reading from bottom to top, just like this, right? So once again, I'm repeating this for you guys, right? So here you go. We are talking about this policy right here. This policy is attached to spokes. The spokes is just nothing but my side ID 1 and side ID 2, right? This is defined by the system. Now, if I say sequence 1 is match TLOC, site hub, it means that when we smart advertise the routes to S1, spoke 1 and spoke 2, it is going to advertise the TLOC of data center. That is it, right? And when it advertises the virtual routes, it is going to advertise all the virtual route, everything, because I have it specified with this any IPv4 prefix, right? And but while doing so, just set the TLOC value to this one, means the next hop is going to be the hub next hop, and that is why we are going to achieve this topology S1, S2, and a data center. The traffic from somewhere who is sitting here and somebody who is sitting here, the traffic is going from here to DC to this one, right? This is as simple as that. Okay, so we are good with respect to making the making this policy. We are going to save this policy, right? But the problem is this policy is not implemented anywhere, right? So what we are going to do, we are going to attach this policy, okay? And we are going to do this activate. Okay, so this is the interesting step, right, guys? So we cannot attach or we cannot send this policy to the vSmart, and we all know that we are going to send this policy to the vSmart, but it is saying vSmart is not in vmanage mode. What is the meaning of vmanage mode? The meaning of vmanage mode is that your vSmart is not managed by vmanage, and if it is not, then basically we kind of cannot activate this policy there. So there are few ways how you can make this vmanage as your what we can say uh, as your vmanage mode. So there is one simple thing, right? So let's leave. We are not attaching this policy to vSmart for now. What we are going to do, we are going into templates, right? If we can, anyway, we can push a template from the vmanage into the vSmart, then we are all good. And to do that, just go to the feature template, right? Or the device template. And we are creating the device template this time from the CLI template, right? Select device model. Device model is going to be, we are creating it for the vSmart. Template name, maybe say it is the template for vSmart 1 or vSmart 1, say, right? And we can, guys, believe me, we can ask the running configuration from right here while selecting. So this is the running configuration, right? Whatever I have. And what I'm going to do is maybe I can change this name from VP Corp, or you cannot change. Means if you do not want to change, you may not. But let's see what's going to happen. If I say this add, I am just doing one thing, guys, right? I am just sending a template so that vmanage can be part of, sorry, vSmart can be part of my vmanage, or the vSmart could be managed from vmanage, so that I can place my templates there, right? So I am going to do this and attach device. This template is only for my vSmart. That is why I have been shown only vSmart. Attach, and here you go. If I see the configuration difference side by side, I have only made one change, that I have changed VP Corp vSmart 1 to VP Corp vSmart. That is perfectly fine. So configure device. Okay, it is going to take some time because we are just pushing the configuration. It is in the progress. So wait for a couple of minutes, guys. So as you can see now, it is validation success. This is good. This is good, but it is still in the progress. So now, as you can see, that I have successfully placed the configuration there. So no problem, right? Now I can say that this device in the vManage mode, not the CLI mode. If you can go to the main dashboard there, or maybe if you can go to the devices there, you can see right here. Okay, so let me just wait a minute, guys. Control minus minus. Yeah, so you can see the mode is vManage mode for these edges. And if I go to the controller, you can also see here that the vSmart in the vManage mode, not in the CLI mode. This is pretty interesting, right? Now I can push my policy there. So if you go to the policies, right? So guys, believe me, I have explained all these things, vManage mode or CLI mode in my theory session. So just go there, try to understand this. Otherwise, these things are not going to make much sense for you. Okay, so we are going into this policy which we have created right now. What I'm going to do is I am going to activate this policy, and if I am activating this policy, it certainly means that it is going to activate on the vSmart, right? Because vSmart knows all the T-logs, all the virtual routes, right? So I am going to do activate. Policy will be applied to the reachable vSmarts, and let's do activate. Okay, the validation success. vSmart is online, right? Let's see. Here you go. You can see the success. It means that the policy changes are applied to vSmart successfully. This is good, right? Now, this is the time to validate that whether our policies or basically our hub and spoke topology is working or not, right? So to do that, let's go into what we call, let's go into the CLI, or maybe we can test it from the GUI also from here. So let's go and test this. And to do that, let's open our vEdges, all the vEdges, okay? So what I did, I have opened I've opened this BR1 VH1, which is my, if you can see on this diagram, which is this one right here, right? And BR2 VH1 is this one, right? The branch 2H1. So I am only interested to see that how many BFD sessions at the first place we are making. Previously, this branch 1 router was making 2 BFD session. If I say BFD session, it means data tunnel or IPsec tunnel, right? So first thing first, show BFD sessions. Okay, let me make it slightly bigger so that it is easy to read this output. Okay, so if you can see, it is making this okay, that is fine. We can read it anyhow here also. Was more easy. Okay, so it is making, let me bring my pen. Okay, so we are here at this PR1 VH1. So previously it was making tunnel with this guy also, right? We didn't want it, and now we are advertising only T-lock of BC edge 2 from here to here, right? And that is why I can see this tunnel. So by the way, guys, this guy 192.168.200.202 is this one, the system IP of this guy, right? Very easy, very simple, no issues at all. Now let's go to BR2 VH1 right here and check the BFD session. Show BFD sessions, and sure enough, we are having the same thing there also, right? So no problem. We are having only two. We are having data tunnels to only our data center, right? And now if I go to PR1 VH1, we want to analyze some more things. Like, let's see what T-locks I am receiving. So show T-lock, sorry for this, show OMP T-lock paths. Okay, so here you go. I had 3 entries. If you would have noticed, means that if you had noticed my last uh, 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 means some of my videos, if you are following them, then basically previously there were 3. Now I can see I have only 2 T-lock. One belongs to only this guy, this one, right? The 192.168.200.1 is this guy only. So it has its own T-lock. That is no problem at all. 192.168.200.1 business internet IPsec, which is this connection, right? No problems. Now it also sees another T-lock from 192.168.200.202, which is this T-lock, this value right here, right? Business internet IPsec, and that is what we had said in our policy, the topology policy, that when you advertise the routes towards spoke 1, this is going to be your spoke 1, this is going to be your spoke 2, right? Whenever this vSmart somewhere here is advertising route from to here, it is only advertising the hub T-lock and nothing else, right? Now it is interesting to check, right, what routes we are receiving on BRV1, right? So similarly, we can straight away check this here also. Show OMP T-lock paths, right? Sure enough, we can see its own T-lock and the T-lock information from the data center. Now, if you can see one more interesting thing, if I do show IP routes, okay, let's make it slightly bigger. Yeah, this is more clearer form. So I like this output because this output presents me all the information, the VPN 0, the VPN 10, and the VPN 512. I am more concerned about this VPN 10 because I'm going to receive OMP route here, right? So if you check, I am on the route, I'm right on this router, BR1 VH1, right? And I am getting routes from this route 10.2.1.0. Where is this route? This one, 10.2.1.0, right? I'm receiving this route via OMP, and the interesting thing to note here that the next hop of this route is not 192.168 uh, uh, whatever the 100.1, right? Not this one. The next hop is 200.202, which is my data center edge, right? It is as simple as that. Okay. If I go to BR2VH1 here, and if I do the same test here, show IP routes, right? You can see right here that this guy, now this one, he should receive these two routes 10.1.1.0 and 10.1.2.0, not with the T-lock of this one, but it should be the T-lock of data center. And this is what exactly we are seeing, 10.1.1.0 and 10.1.2.0. These two routes learning via OMP with these two things, right? Very simple. And this guy is also learning these routes from the data center. 10.100 routes are data center routes, and basically again the same thing, no issues. And this is just intact with our policy, right? And what is that policy? When vSmart, okay, let me explain this to you over this. When this so basically there is a tunnel, right? There is a direct tunnel from here to here and here to here. We are running OMP over it, right? And we have configured a policy into this vSmart, which was pushed from this vManager, right, in outbound direction. where we are saying in terms of virtual routes, whatever routes you are advertising, right? To spoke 1 and spoke 2, you need to advertise them, right? You need to advertise them, but make sure when you advertise them, you change the next hop or the T-lock information to DC T-lock, this one, which is 192.168.200.202, right? It is as simple as that. Now, we need to check whether we are able to successfully ping or not, right? The path from here, the branch 1 user 1 to branch 2 user 2, the IP address of this guy is 10.2.1.50, right? It should go from here to here, my branch router, the default gateway. Then the branch router default gateway is this one, right? It should go to DC edge, right? And from DC, it should go from here to here and here. So we have broken this topology, the full mesh, and now this was our DC, this was our branch 1, this was our branch 2. We made sure that there is no such link, and the next hop should be this one, right? And now if I do a ping from branch 1 user 1, it should go from here to data center first, and then it should be receiving here, right? So let's test that. So before doing the ping and trace route test, and I'm just clearing this screen. And right now, if you can see, I am in branch 1 user 1. Okay. So branch 1 user 1 means this PC. I am right here, and I will be bringing branch 2 user 1, which is 10.2.1.50. First of all, the ping should be successful, right? Let's see. I'll do ping 10.2.1.50. Simple. Okay. Okay, this is interesting. So I made a mistake. So I am in branch 1 VH1, guys, right? So obviously it is pinging the VPN 0, and it is not going to find that. So I should be on the branch 1 user 1 here, right? So let's do a ping. If you had done this ping from the VPN 10, it would have pinged. So no issues there also. I will show you. I'll show you. So 10.2.1.50. And sure enough, we can ping this. Now, I want to do the trace route for the same 10.2.1.50. Okay. And let's see which path it is taking. Okay. So this is good. I'm just bringing my pen once again. So here is my pen. Okay. So first hop is 10.1.2.1, which is this one, right? The second hop is 10.1.1.1. This is this network, and the second hop is this one. You can just match whatever the IP addressing we have been using, right? The first address is the gateway, right? And this is the range. Now the third hop, which is the most interesting one, 10.100.2.1, which is IP address configured here, 10.100.2.1, right? So it means that the traffic is going from here to here first, right? And then the fourth hop is 10.2.1.1. I think it is here, 10.2.1.1, which is the IP address we have configured here. And the fifth hop is going to be your host, because this is a switched network, right? This one is your fifth hop, and that is what we were planning to achieve from this complete conversation, right? Guys, the video is slightly long. It is approximately 1 hour 35 minutes, but believe me, if you understand this, you are pretty good to start exploring more of SD-WAN policies, right? till now we have just covered centralized policy, guys, right? And inside the centralized policies, there are two, the control and the VPN, right? We have just covered the control portion of it, right? Inside the centralized policy, we have data policy also, right? Which we have there, like application aware routing, and then yeah, so much. And just like the centralized policy, we have the localized policies also. But believe me, if you understand this, carrying hold of all other things are not going to be very difficult for you, right? See this video as many times as possible if you want to be expert in SD-WAN. Okay. So having said that, I would like to take your leave and see you in some other video. Thank you so much, and just watch the other videos for the fundamentals of SD-WAN, right? Having said that, bye for now. See you later.